Okay, so finally, 17 years later, isosceles triangles. So we already know what they are. We already know that an isosceles triangle is a triangle that has two sides, at least two sides congruent. Okay, that's the official definition. So if it has all three sides congruent, yes, we call it equilateral, but by definition, it also does fit into isosceles. Okay, great. So, I'm always going to have two sides of the triangle that are congruent at least. Okay, if I'm going to have isosceles, that's part of the definition. Now, what's so cool about isosceles triangles, besides the fact that they have two sides congruent, we've already mentioned this a little bit. If two sides in a triangle are going to be congruent, that means two angles are going to be congruent. All right. And it works all for all of them. So if all three sides are going to be the same, then all three angles are going to be the same. So if two sides of a triangle are congruent, then two angles are congruent. Furthermore, it's not any two random angles. It's always going to be the two angles across from the sides that are marked. Oops, let's spell always, right? All right, so I have two sides that are going to be congruent. Two angles are then also going to be congruent. And it's always going to be the angles across from the sides that are marked. So in other words, if we take a look at the diagram that I've drawn here, you have two sides that are already marked congruent. So what I'm telling you is that the two angles across from them, so if I take a look at this side, the angle across from it is this one over here. So this angle is going to be the same as across from this side is going to be this angle. So those two angles down here, let's call them angles 1 and 2, are always going to be the same. Okay, so angle 1 equals angle 2. One thing that kids mess up sometimes is that they get so used to being angles 1 and 2 being on the bottom, but they won't always be on the bottom. So let me draw you another. What if your triangle looked like this? And it was these two sides that were congruent. So now the angles that are congruent aren't going to be these two bottom ones. It's still the ones across. It's almost like this. If you imagine this was an arrow, it would be pointing right at the angle that it's talking about. If that were an arrow, it's pointing at the angle that's going to be congruent. So here, there's angles 1 and 2 this time, and they will still be equal to each other. So if you have an isosceles triangle, you're always going to have this pair of angles congruent to each other. Gosh, if only there was a name for this pair of angles. But there is. They're called base angles. All right, so let's add that to what we already have here in words. If two sides of a triangle are congruent, then two angles are congruent. It will always be the two angles across from the marked sides. So let's just say they are called base angle pairs. Oh, come on. Oh. My camera is rebelling again, apparently. It's just stuck there. All right, let's try resetting it. I don't know what is the matter today. right, there we go. Oops. So I have these base angle pairs that are always going to be the same. We do have a name for the other angle, the one where the two sides that are marked meet. We call that angle the vertex angle. So this, it's not going to be equal to these other ones, but it does at least have a name. So vertex angle. So you might have a problem where they only give you a vertex angle and then you find the two base angles. Or they might give you a base angle and ask you for the others. So let's actually try a couple like that. So let's do solve for the missing angles. Let's start off easy. If I give you this and I told you this angle was, I don't know, how about 60 degrees? Oh, no, I don't want 60. Just kidding, just kidding, just kidding. I want 70 degrees. I would like you to find me the measures of angles 1 and 2. Take a minute. I'm going to zoom in a bit. Find me the measures of angles 1 and 2. All I'm giving you is that 170-degree angle. How are you going to find the others? Who's got an answer for angle 1? Yes, 70. Thank you. Yes. If I have an isosceles triangle, the two angles across from the sides, those base angles, these two are going to be equal. So this angle here and this angle here are the same. So if that one's 70, then angle 1 is also 70. All right, great. Now, how are you going to find angle 2, though? Does anybody have an answer for angle 2? Yes, 40. Where did 40 come from? We can't just snatch numbers out of the air.
Because
Where did 40 appear from?
there's 3 angles, so you have to, like, I don't know, subtract 30 from 70.
Yes. Don't forget, we are still dealing with triangles, and triangles always add up to be 180. The 3 angles do. So 70 and 70 is 140. I need 40 more to get to 180. So that's how I end up knowing that angle 2 has to be 40 degrees. Okay, let's try another one. So here is your triangle this time. And what if I gave you, this time I'll give you that this angle here is 100 degrees. Could you please find me angles 1 and 2? Yes. Oh, Chase is on point today. I only have one answer so far, though. Oh, yay! 2 answers, and they're both right. So hopefully you're looking at this and you're like, okay, I have an isosceles triangle again, right? So the base angles are going to be congruent. But this time, the base angles across from the two sides that are marked, it's these ones down here. Those are the ones that are going to be congruent. So what I need to do is say, okay, well, all 3 angles have to add up to be 180. I already have 100 accounted for right here. So that means these 2 angles have to add up to be 80 together if all 3 are going to add up to be 180, right? So if these two are the same and they both together add up to be 80, the only combination is 40 and 40 that would work. So angles 1 and 2 are going to be the same and they're both going to be 40. Ooh, be careful. So sometimes I'll give you a base angle, sometimes I'll give you a vertex angle. You never know. So try this one. This time I'll give you, I'll give you that this angle here is 30. So please find for me angles 1 and 2. In this case. So if I were you, I'd start by figuring out, well, which two angles are going to be the same? Because in every isosceles triangle, you're going to have two angles that are the same. So which two is it? Chase, you've got it. Haley, which angles are equal to each other?
Never mind, I'm being stupid again.
So remember, it's always the ones across from the ones that are marked. Or you could think about it another way. The angle where the two meet, the two sides that are marked meet, that one is not the one that's congruent. It's the other two. So where these two lines meet, the two marked lines meet, this one is not the one that's congruent. So it's these two are equal to each other. So I know that this is 30, and that means this one will also be 30. So now I can find the third one. So if I have 30 and 30, that leaves this one's got to be, yes, I'm getting some right answers, 120. So angle 2, 120 degrees. Okay, so it's going to change every time which angle they give you. You just have to ask yourself, well, who is congruent? And it's always, 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 no matter what your triangle looks like, because isosceles triangles can look all sorts of different ways. I don't know. Say you had one like this. You're always going to have two sides that's marked. Okay, the angle where those two sides meet, so let's just number these angles. The angle where those two sides meet is angle 3. That's the vertex angle. That's the odd man out. It's these two that are going to be the same as each other. Okay, so, and I could give you any one of these three angles. That's what's so neat about it. Before, with triangles, I'd have to give you two angles for you to find the third. Now, if it's an isosceles triangle, you only need one angle and you can find all the other bits. Okay, so the only other thing that I think is on your homework tonight is problems like this. You might see, let me just give you, oh, you know what? We can do two problems in one. I love that. Hold on. Let's draw this triangle a little bit better. All right, so let's say this is your triangle. I might do something like this. Let's say, oh, let's say this is 35. I might ask you to find angles 1 and 2, and then I might also say that this is x plus 10, and this is 30. So could you find me the measure of angles 1 and 2 and the value of x? I think you can. Try it. Okay, do we have an answer for, well, let's go back to, so looking at just this triangle, which two angles are the same out of these three? So I have three angles, angles 1, 2, and then one marked 35. Two of them are the same as each other. Which two is it?
Angle 2.
Angle 2 is the same as?
35.
Yes. So if this one's 35, that means this one is also 35. All right, cool. So now I can find angle 1 pretty easy. If I have 35 and 35, what's that? 70. Take that away from 180. That means angle 1 has to be 110 degrees. All right, perfect. So I have that part of the problem done. I still do need to solve for x, though. So what's going on with these?
Wait, I have a question.
Yeah.
Why is it 110 degrees?
So 35 plus 35 is 70, right?
Yeah.
So don't you have to do 180 minus 70?
Oh, yeah, I did my math wrong. I thought it was 10. Never mind.
So what am I doing with the sides of this triangle now? I have x plus 10 over here, and I have 30 over here. What's the deal with that? Is there a way to solve for x?
You make them equal to each other?
Yes, these are just side lengths, and the sides are already marked equal. So I'm literally just going to write x plus 10 equals 30, and I should be able to solve for x in this case. So that's easy enough, just minus that 10, and I get 20. All right, that was fine. Now I have one last problem for you to try. Take a look at this one. Oops, wrong way, sorry. See if you can solve for x in this picture. Feel free to send me an answer when you got it. I haven't gotten any answers yet, but I feel like they're coming. Yes, I got one from Elizabeth. That's right. Chase, that's right. Okay. So here's the deal with this one. I keep telling you, there's always going to be two angles that are the same as each other. And it's always the two that are across from the sides that are marked. So yes, it just so happens to be this one and this one. So those two are in fact equal to each other. Those are my base angle pairs. So I can just go ahead and write an equation and then solve it nice and easy. So I should have 2x minus 2 equals x plus 4. And then I just solve like I always do. So I end up getting 6 for x. Okay, and you should be able to check this if you pop it back in. 2 times 6 is 12 minus 2 is 10. And then 6 plus 4 is 10. Yep, so I know that I'm right. Yes, okay, so I'm pretty sure that is it for the notes here. So let me go ahead and make your homework live for you. So this homework is it on CUDA? Yes. All right, give me a sec. I'll make it live. And if you feel confident and ready to go, then you can go for it. I will do a couple out with anybody that wants help on it. What's this? All right. Okay. This should be homework 9. Oh yeah, isosceles triangles. Okay, good. Ooh, it's cold in my house today. All right, B block. All right, it should be, oh, okay. All right, it is ready for you in CUDA. So if you're ready, just go for it. If you want me to do a couple, then pay attention here and I will do that for you. So let me just share this. So you're going to start off with some that are very straightforward. You just have to solve for the one missing angle. Be careful because you need to make sure that you know which two angles are going to be the same. So in this case, it would be these two angles are the base angles, right? Because they're the ones that are across from the ones that are marked. So if those two are going to be the same, I need to do 180 minus 70, and that's how I get down to 110. And then if these two are going to be the same as each other, I'm just going to take 110 and cut it in half. That's how I land on 55 for the value of X. Okay. And every one, they're going to change what they're giving you. So this time, well, let me do one. Okay, so here's one. They gave you one of the base angles. So this one and this one are the same. So if that's 49, this is also 49. So now to find X, I'm going to do 49 and 49 is 98. Take that off of 180. And what's that, 82? So be careful. So every time it's going to change. So you can't just always do the same thing. What will always be true is that in an isosceles triangle, the two angles across from the sides that are marked will be congruent. But if the two sides that are marked are going to change, right? So if you had this, now it's these angles. If you have this, now it's these angles. So just get used to it always being the two angles across from the sides that are marked. And then you should be able to do the rest of the problems. Okay, so let's just speed through here. There's a whole bunch I have you trying like that. And then these, oh yeah, can everybody look at this one? Because we actually didn't do one like this. Here, see how they've marked two angles the same? If two angles are the same, that means the two sides have to be the same. So that means that the side that's marked X has to be 12. They've got to be the same. All right, let's try another one of these. Well, that's an equilateral one, so let's do here. So if that's 6 and the other side's X, these are the sides that have to be the same because they have the angles marked the same. So if the angles are the same, that means the sides are the same. So this one's got to be 6. Okay, so hopefully those aren't too bad. If you get to one of these ones where it's equilateral, see how all 3 angles are the same? If all 3 angles are the same, then all 3 sides are the same. So it's just, they'd all be 9. All right, and then you're going to eventually hit ones like this where you have to do a little bit of algebra. Remember that the sides are going to be the same. So I just do 2x minus 6 equals 12. And then I should be able to solve from here. So it looks like X is going to be 9 in this case. All right, so let's see. Is there any other type, or is that it? That's it. Okay. So, does anybody have any questions?